square root of a number, or computing the power between any two numbers. Then there is a special class called math that provides many of these standard calculations as methods. This class is automatically provided in your program, so there is no need to write the keyword import like what we have done for the scanner class. It is available all the time in your program because these methods are defined as static methods. And remember, for static methods, if you want to call them directly, you can use the name of the class. So if you want to use any of these static methods, simply write the name of the class, which is math, M capital letter, followed by dot, followed by the method name for this mathematical calculation or for this mathematical method. The class not only has static methods, it has also some static constants, some well-known constants that are used in mathematics. For example, it has the constant pi, and you know that pi is used in calculations involving circles, spheres, and other geometric figures based on circles. And you know that the value of pi is approximately 3.14159. So if you want to use this constant in your calculations, you can use it from this class. Also, there is another constant, which is e, that is used in mathematics for natural logarithm. And you know that e is the base for natural logarithm, and its value is approximately 2.71828. Let us have a look into some of these mathematical methods. In this example, we are showing 4 of these methods. In the table, we have the name of the method, we have a description, what is this method is used for, the type of its argument, and the type of its return value, an example, and the return value for this example. POW is for computing the power between any two numbers. It works on double numbers, and the return type is also double. As an example, if you want to use it, you write math.pow power and you put the two numbers. So here it is going to compute 2 to the power 3, and the answer is 8. ABS is for the absolute value, and it can work on these data types, integer, long, float, or double, and it returns the same data type. So if you are applying the absolute value on float, the return value will be float. Here are some examples. Math.abs minus 7 will convert it to 7. Math.abs 7 is already positive, it will return the same number. And for double or float, it returns the same data type. The last two methods in this table are used for finding the maximum and minimum between two numbers. Their input data types can be integer, long, float, or double, and they return the same data type. As an example for maximum, here is finding the maximum between two integers, and here is an example of finding the maximum between two doubles. Similarly, as an example for finding the minimum between two numbers, here is an example of finding the minimum between two integers and the minimum between two double values. Also, in this class, it has the following mathematical methods. Random is used for generating random numbers. It does not require any input parameter. So if you want to use it, you include empty round brackets. And it returns a double value, but in the range from 0 less than 1. So it gives 0 as random number, but it does not give 1. And it is from 0, so that means it generates fractions between 0 and 1. We will show you an example on how to use this method if you want to generate integer numbers in a range. So suppose you would like to generate random numbers from 1 to 6. Then we will show you how to write a formula using this method to give you the answer. For rounding a number, its input parameter is either float or double, and it can retain these data types, integer or float. When it says respectively, it means if the input is a float, it retains integer. If the input is double, it retains long. it rounds this number and converts it to integer, and it rounds it to the closest integer. So as an example, here we have 6.2, then it rounds it to 6. But 6.8, it rounds it to 7. So that means after the decimal point, if it is 5 or above, it adds 1 to the integer. Next, we have two also other methods for converting double into integer. One is called ceiling, the other one is a floor. Both of these methods, their input parameters double and they retain double. For ceiling, it rounds the number up. So if it is a 3.2, it rounds it to the integer that's on top of a 3.2, which is 4. And for a floor, it rounds down. So it rounds the number closest to the integer down, even if it is close to the top number. For example, 3.9, it is close to 4. But the floor, it makes it close to the down number, which is 3. So that means it ignores the fractional parts. For a floor, it ignores the fractional part. 3.2, it becomes a 3. 3.9 becomes a 3. However, for ceiling, it makes it to the top integer. Even if it is close to 3, 3.2, it will make it to 4. And 3.9 also will take it to 4. Last, we have the square root. And if you want to use the square root, it works on double and it retains a double value. As you see, this is an example of the square root of 4. The answer is 2. Now let us return back to the random method. As we said, it generates random number in the range 0 to 1, including 0 but not including 1. Now how to use this method to generate random integers in a range between start and end? The answer is by using this equation. First, we multiply math.random by end. Next, convert it to integer. Then we add it to start. To show you how this equation works, suppose we want to generate random numbers from 1 to 6. So start is equal to 1 and end is equal to 6. Let us first consider the first part of the equation, which is end multiplied by math.random. The result is converted to integer. What is the minimum generated number by this method? As mentioned, it is 0. So 0 multiplied by end, which is 6, so the answer is 0. So that means this part of the equation, the smallest value is 0. Now what is the maximum generated number that we can get from math.random? Notice here it says less than 1, so it never reaches 1. So when you multiply this value end, which is 6, by this, let's say 0.999, then it will never reach 6. So when it's converted to integer, then the maximum value we will get is 5. So the range we will get for this part of the equation will be from 0 to 5. But we want the range to be from 1 to 6. So therefore, to make the shift, you add 1, which is the start. So if it is 0, it will be converted to 1 because you are adding 1. If it is 2, it will be 3. If the generated number is the maximum 5, you add 1, it will be 6. So therefore, this equation will give you random numbers from 1 to 6. Let us write a smaller program in JGrasp to show you how to use the random method. To use random method that exists in the math class in our programs for generating random numbers, first let us see what this method is giving us as an output. So we will print a message system.out.println and we will say random equal to, and we will simply call the method math.random with empty input parameters. Run the program, and as you see that it is generating random number between 0 and 1, including 0. Let us run the program again, and it is generating another number, and etc. Now I want to generate 100 random numbers. So we will create a for loop for integer. Let's say I equal 1, I less than 100, I plus plus, and then we will put this statement inside, and we run the program again. But again, it is listing all numbers one after the other. Suppose I want to print these numbers such that 10 numbers on a line. So we will use here tab and modulus to count how many numbers we can print on a single line. If it exceeds 10, it goes to the next line. So inside we will write an if statement. We will say if the value of I modulus 10 is equal to 0, then we will print the number without a println followed by a new line. Or we can just simply use a println instead of a new line. Otherwise, we will simply print, copy this statement and paste it here, but remove \n and put \t. Now we run the program again. We have an error. Yes, I forgot to close the bracket. We will close the bracket now and run the program again. As you see, we are printing 10 numbers on each line for 100 numbers. Because the random numbers are large, so we cannot see them all fit on one screen. We want now to generate random numbers between two integers, between let's say let's say start and end, and start and end we are going to read them from the user. So integer start, comma, and end, we will print a message, enter two integers. Start is equal to read dot next int, so reading the first number, and equal read dot next integer as well. Now we need to make sure that start is smaller than end, so we are going to say if start larger than end, then we will do two things. We will display a message on the screen, system.out.println. We should write the first number should be smaller than the second number, and we will quit the program by saying system.exit with 0 parameter. But if the first number is smaller than the second number, then here we should change the equation. Probably we want to save it into a variable. We will call it rand, and we write the equation. So as you recall, that the equation we are going to write should be end multiplied by math.random. The result is converted into integer, typecasting, and then we added to start. So here it will give us a random number in the range start to end. Run the program again to see how it works. So it is asking for two integers. Let us give the first value 6, the second value is 1. So the first number should be smaller than the second number. Run it again. If I give it 1 and 6, and oh, I forgot to change here and put rand, the value of the resulted expression, and then we run it again. Put so 1 and 6. So as you can see, it is generating random numbers from 1 to 6.